Let's work through question 14 from chapter 9. So the question says, consider the following hypothesis test. Our null hypothesis is mu equals 22, and our alternative is that mu does not equal 22. It says here a sample of 75 is used and the population standard deviation is 10. Compute the p-value and state your conclusion for each of the following sample results. Use alpha equals 0.01. So we have two different parts here. We're going to find a p-value if our x bar is 23, and then if x bar equals 25.1. So to find a p-value, we first need to find a test statistic. So we can use a z-score here. We can use a z-score because sigma is given and our sample size is greater than or equal to 30. So we were able to prove that we could use a z-score. So now we can plug in the pieces that we know into our z-score formula. X bar is 23. Mu null, that's going to be our 22. Sigma is 10. And n is 75. So we plug all of that into our z-score formula. And we will find that our test statistic will come out as 0.87. So now we can use this 0.87 to find our p-value. So before we put the 0.87 on our bell curve, we first need to look at the sign in our alternative hypothesis. And we see that it's not equal to. Whenever we see that, that tells us it's a two-tailed test. So our test statistic is going to be positive 0.87 and negative 0.87. So to find the p-value, we're going to need to know the areas in both of these tails. We need to know the area to the left of negative 0.87 and the area to the right of positive 0.87. So if we look in our z-score chart for negative 0.87, we'll see that that area is 0.1922. And since a bell curve is symmetrical, that means that the area to the right of positive 0.87 is also 0.1922. So now we can come up with our conclusion. So this rule that we have is that if the p-value is less than or equal to alpha, we will reject the null. Well, to find the p-value, that's going to be the total of the areas in the tails. So the left tail is 0.1922, the right tail is 0.1922, so we add those two together and we find that our p-value is 0.3844. Well, our alpha is only 0.01. So since our p-value is greater than our alpha, we do not reject the null hypothesis. So that's our conclusion here for this first part. Now for the second part of the problem, our x bar has changed to 25.1. We can still use the z-score because our sample size is still greater than or equal to 30 and sigma was given. So we can plug in our new number for x bar into our z-score formula. Our mu null, our sigma, and our n are still the same as they were in the first part. And what we'll find here is that our z-score comes out as 2.68. So we'll use that test statistic to now find our p-value. So we once again notice that the sign in our alternative hypothesis shows that it's not equal to, meaning we have another one of these two-tailed tests. So we put negative 2.68 and positive 2.68 on our bell curve. And to find the p-value, we need to know the areas in each of those tails. So we'll look up negative 2.68 in our z-score table, and we'll see that that area is 0.0037. And again, since the bell curve is symmetrical, we know that the area to the right of positive 2.68 will also be 0.0037. So again, the rule that we have is that if the p-value is less than or equal to alpha, we will reject the null. So we need to find our p-value. What we do is we add up the two areas of the tails, the 0.0037. We add those two together and we get a p-value of 0.0074. Our alpha is 0.01. So our p-value here is less than or equal to our alpha. So our conclusion that we make is that we reject our null hypothesis.